Meena is there. Sanjeev Rajnikant. So Mobin is not here. Rajnikant, your group member. Mobin is also there.
He'll be joining after some time, sir.
After.
After few minutes, he will be
After
joining.
few.
So can you all look at my screen?
Yes, but I think you need to put it in a landscape mode.
I understand, sir. I mean,
Yeah,
I
you
can
just
get.
you are presenting from your mobile, correct?
Yes, sir. Yes, sir.
So put it in a horizontal mode basically. Not,
That's why it looks very small.
uh,
To us, when I look into it, yeah, a little bit better
it
now.
should be
Yeah.
better. And I, if it's a PPT, I think you can present it also. You can put it in a presentation mode. Okay. Or you just click on this play button. Click on the play button. There is a play button. No?
Yeah.
Yeah, this is a presentation mode. Okay. So, Abhishankar, are you there? Hello, Abhishankar. Just give us a minute. Let Abhishankar
Yes.
also.
Yeah, yes, Himanshu, I am available.
You are there, so but one group member is not here. So what should we do? Shall we wait for him? Any update, Meena, when he will be joining?
So he'll be joining just a few minutes, sir.
Okay.
Sir,
I think someone has joined. Yeah, he has joined. Okay.
he's taking some time.
Just give me a minute. Meena. Okay. So, 55 and 40. Yeah, I think we can start. So, Meena, you
Yes,
need
sir.
to highlight. Yeah, yeah. So, who is going to present?
Yes, sir. I'll just take you through all the stages of our presentation. Uh, Basically, the presentation is on the machine learning technique of minimizing the ring blowholes, sir. Basically, it is a foundry defect, casting defect at the stage of casting in a piston, where at the ring stage we'll be getting this defect. Well, in the production stage. So this project has been done by four of us: me, Mobin, Sajid, and Rajnikant, sir. So
You need to highlight the contribution of each member also, by the way.
yes, sir. Yes, sir. So all the technical details and any knowledge on this topic was have been inputs have been taken from me, and from there Mobin has did the journal study and he has did the EDA part, and from there Sajid has taken it in the experimental aspect and did the model creation, and even Rajnikant sir also has helped us in the model creation, and from there Rajnikant sir has did the machine learning algorithms. So I'll be doing all the introduction part, and from there Mobin will be taking you to the EDA part, which he have done from the journals and also from a lot of experimental studies.
Okay.
And Sajid will be doing all the data visualization model creation. He'll be explaining how the data visualization done and how this model was created. And last, the Rajnikant sir will take you to the observation part, what we have observed, what is the result we have got, and how we have concluded it with the points we have given suggestions to the foundry. So I present myself. I'm Meena Manogna. So I'll be doing all the introduction part on the technical aspects on from where we have taken this and how we have did this. So the goal of this project is to minimize any kind of blowhole, sir, at the ring area. So because when there are ring blowholes at the ring area or at the pistons, what happens? There is lot of blow by in the engine, and also there are chances of engine failure. So that is one of the reasons where we'll be having, when there are lots of blowholes or lots of defects in the foundry stage, we will be having to, because of production in the casting section itself, lots of energy of a person or a machine will be taken, and also the cost of the piston will be going down. So
Can you
we have,
enlarge your, excuse me, can you enlarge your presentation a little bit? Okay, okay, go.
is it
Yeah,
okay?
that's all right. That's all right. That's all right.
So we have did the simulation techniques, and we have also used the machine learning part. So in this we have taken into the parameters, we have taken into consideration, or what is the, how much amount of the pistons are inspected, what is the scrap, what is the temperature content. We have taken that part, and we have also taken the consideration which we didn't include in the machine learning is the gating system or the venting angle or the tilt angle. We didn't include it in the machine learning part because the angle is set, and obviously the gating system is also fixed at a particular position, so we don't be changing it every single time, but temperature can vary, and also the scrap is getting varied. So that is one of the reasons we have not taken into consideration while doing the machine learning part, the gating system and the tilting angle. You can see this part, right, sir? Venting, pouring angle and all.
No, actually.
Is it okay now?
Yeah. So you can actually, I don't know, you can cross this, na? There is a cross button, I don't know.
Now you all can hear my voice also.
Yeah, we can hear you, we can see this presentation, full screen.
Yeah, then that's fine. So the points which were considered to the machine learning is temperature, scrap, and inspection. The points which we have done to the magma simulation are gating system, venting system, and the pouring angle. So as you all know, what is a piston? Piston is a component. It will be used in reciprocating engines. It is basically used in the cylinder parts. So it is also known as the heart of the engine. So the place where we were doing this project on was at the ring area. So at the you can see this is a piston crown, sir, and I don't have a cursor to show, but at the top crown, the second top compression ring, second compression ring, and the oil ring. These three parts are the rings where we are getting lots of blowhole scrap. Blowholes or the line defects, which is basically due to the air bubble entrapment. So the alloy specification which we are using into this is silicon. Aluminium will be the 60% to 80% of aluminium. This is an aluminium factory. So aluminium will be used by 80% of aluminium is used, and apart from that silicon, copper. So silicon will be the second position. Why we have taken alloy into this one is basically when we are doing the temperature part or the steering part, sometimes due to higher temperature specifications of certain metals also can be a reason when we have this blowholes, because
This
some
is
of the metals are,
yeah. This is like eutectic alloy, correct?
yes sir, yes sir, iron and manganese. So as you can see, this is the ring blowhole. You can see a very big blowhole, and this is the line defect.
So how do you
The
get this
first one,
all? Just my one question, that you showed these compositions of this alloy, right? So is it already the? I mean, in the supply itself, it is informed that what is the content of this alloy, or how do you
yes
get
sir,
that?
we get it from the customer itself. The customer explains to us that he wants this kind of specification into it, that we have different types of alloys, like some are normal alloys and some are high runner alloys. So in this, you can see the iron content is 0.8% maximum, and some of the pistons we get it for 0.5 maximum. That is for fast moving, like if you this is a particular application for tractors or small what we say moving
Yeah,
rovers
yeah.
and all.
That's what I am trying to understand. So your data or whatever sample you have collected, that contains a wide range of this okay um, alloy composition. That means
Yes, sir, yes, sir.
iron can be okay 0.8 maximum, but it can be as low as 0.5, 0.6, or something like that. I mean, it can be have a various range. Similarly, silicon and magnesium, all these things, that would be manganese also, that will be different specification, right?
Yes, sir, yes, sir. It can be on depending on the specification. This will be given to us by the customer himself.
Okay, so for all each and every data, all these compositions are given. Okay,
Yes, sir. Yes, sir.
okay, go ahead.
Yes, sir. So the first piston is a blowhole, ring blowhole, and the second one is line defect because it is in the form of line, curved line, or anything you can see. This is in the form of blowhole. So this is the smallest one, ranging from that big to this small. I think these are the defects in the pistons we have observed, sir. These are mainly due to blowhole is due to entrapment of air while we are doing pouring. When we are doing pouring, the air can be entrapped due to fast pouring, or when the tilt angle is when the machine is tilted to a certain angle, there are lots of chances that the air can be entrapped at that position. If the gating system where the gating system is very narrow, there are chances of getting a blowhole. So those are the particular points we have taken into it. So you ever see when a confined mold pocket is filled at a faster rate, then the venting system and mold permeability can sustain the cushioning effect of the trapped air delays. So then there will be an airlock system into it.
So Meena, can you measure pouring velocity also?
So that is the issue, sir. We are not measuring two types of things. One is moisture content and one is pouring viscosity of that velocity. Huh?
Okay.
That is
Is
where
there
we
any
have
methodology exists to measure it, or it does not exist?
we don't have it, but in the long run we are planning on putting that. But as of now, we don't have that
No,
methodology.
but you don't have, but it exists somewhere. It is. Correct.
In our
You
plant, it
can
doesn't
hold it.
exist. Yes, sir. Yes, sir. In our plant, it doesn't exist. But yes, it does exist no elsewhere.
Okay.
Did you measure viscosity, or did you get the data of viscosity?
No, 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 sir. We don't have viscosity measurement.
Uh,
Even the hydrogen content also, we don't have how
uh,
much hydrogen
so,
content is there in the.
so it was not a parameter in your analysis, was it?
No, sir. We have tried to take it. We have tried to check it, but the measuring system was not at all. What we say, it was not very good, and we didn't get a very good number. We didn't good very good measurement
Yeah,
analysis, so that was the
yeah,
reason we have stopped it there.
yeah. That's not easy either. That's why I wanted to know whether you have any supply data or not. Okay. Okay, go ahead.
Yes, sir. So from we have it in spiked from at the month of January to February. We have a lots of spikes into it. It was not like that before. We didn't have much defects, but over the time the defects have been picked up, and due to one of the reason can be after COVID lockdown, some of the machines has to be started. So when we start a machine after a long when we start a casting machine after a long time, there are chances some of the scraping was not done properly, or these also can also be the reason. So that can also be the reason for the spike. So in the month of August we have the defect. The red one is a line defect and the blue one is a ring blowhole. So from there you can see
And what
that
is green one?
the
What is green one? Green line.
green one
What what does
that
it?
is that is the inspected parts, sir. How many parts were inspected in that particular month? So for
Okay.
this particular piston, we have inspected 21,000 pistons, out of which we have 10%, 10 is the scrap, and 24,000 pistons were inspected in the month of September, and we have got a scrap at around 11%. And if you can see, the graph has increased the month of January, only 31,000 pistons are checked, and almost 44% is the scrap. And in the February also. So that is when in the March we have taken up this project.
Oh, what was the reason behind this peak in January?
One of the main reasons is due to stopping of the machines where as you all know, there was a very low peak into the orders into the DCM sections, the manual casting sections. So due to which all of our furnaces were stopped for a very long time. And once it was started, we had due to some of the scraping parts or the some of the temperature not attaining at a particular metal not attaining at a particular temperature. These are some of the reasons where we have observed more than half of the pistons were getting scrapped.
So it was again. It was seen. Just go. Yeah, just hold on here. So it is seen in month of February. It is dropped to how much? It is 21,000, or it's more than 21,000. Number.
Inspected parts is 21,000. Yeah, the orders we got is around 22,000 or 23,000. We have
Okay.
inspected 21.
Okay. But did you not get? Did you not take any other data in the month of March or April or onwards in 2021?
Yes, sir. That is after the analysis part. We have kept it there. This is till
Because
this is
you
the
cannot. I mean, what my point was telling this thing is that you cannot judge. Okay, maybe if you do not see another 2 3 months how the data is, and if you show their graph, then it would show that pattern how it looks like the defect.
no. So till the month of July, we have the full data. Only the part is till here we have taken into the analysis part. We have analyzed this data and then we have taken this data and applied some of the measures. And then we have what is
My
a drop down
question
or
is,
what is it?
my question is, in the month of March or April, did it drop or did it increase the
It
number of
has
defects?
dropped. It
It
has
has
dropped.
dropped.
Initially, we have
That means
given some of the points. Yeah.
steadily it dropped. Okay. All right.
So this is the die-wise data. Dies. So for a particular piston, we have 4 dies, sir. In that 4 dies also, we have observed some of the 2 dies are giving a much rather scrap rather than the other 2. Like here, you all can see. Yes, sir.
Nothing. Nothing.
Okay. So the blue one is 113, red one is 114, green one is 115, and the purple one is 116. Uh, the die numbers are given once a die has a life of 3 lakh pistons, sir. Once it produces 3 lakh pistons, it goes for the rework. If it can produce more than 3 lakhs, we use it. If it can't, then we'll scrap the die and we'll take the new die. So when we take a new die, then we'll give the die number to it. So that is how it is got the number 113, 114, 115. So in this, we have observed that in the month of January, February, as you can see, March, April, and May, it has a lower scrap. January and February, we have much scrap in 114 and 115. So I just wanted to,
Yeah, just I'm curious to know, like earlier you have presented data till February. Now you are presenting, you are comparing January, February with March, April, May. What is the reason?
yes, sir. Sir, actually, I wanted to point out here also, uh, much of the April and May scrap we can't take it into consideration because one of the reasons being lockdown has started from the month of in the end of April until May. So the data stands invalid, but we have what we have did is in the month of March, after the month of February, in the month of March, we have given gating system changes. We have observed that some of the gating system has a narrow part, so we have asked the change. So we have observed very low peak into that after changing it to it. So that was one of the reasons I've compared that February with March and April. But if you see the inspected parts, it will be very low compared to the January and February. So you can see here, the ring bund has a what we say, it is in the misleading alignment. So the upper part and the lower part are not aligned with each other. One of the reasons being there is a reason where we are getting a scrap. When we are pouring, the bubble is getting stuck there and it is not moving up. And one of the reasons is, as you can see, these are the die-wise data. Our lowest scrap is in 116 and the highest scrap we have observed in 114 and 115. So 116, we have a very thicker, broader ingate with 4.10, the thickness of the ingate, and the rest is 3.8, 3.3, 3.2. So that is one of the reasons we have, as I said, we have changed. This is the modification we have did in the month of March. We've asked them to increase the length of the ingate, also the thickness of the ingate area. So this is how we have did from research. We have taken the hypothesis and then we have given it to the, from here I've given all the data to rest of my team members, Mobeen, Sajid and Rajnikant sir, to analyze the test with the experiment and analyze the data, and any conclusions we have given it to my company. So this is the agenda, to have a zero defect, because whatever produced, especially in foundries, people work at a 700 degrees centigrade. It is not easier to work there. So whatever scrap they produce, in the end of the day, they will be measurable for that also. Their salary gets deducted. So that is our focus area, to reduce the scrap. So what we have did is, in the die, we have given ribbon air vents at all positions, at 11 o'clock, at 10 o'clock, at 9 o'clock, to have a good ventilation, to get a good venting, so that the air bubble which is formed in the die itself, it gets removed. So we'll come to the actions taken part in the next area. So I'll ask my teammate Mobeen to next start with EDA.
But how do you come to the conclusion that air bubble is the reason? I mean, from the analysis or some other way?
No, sir. This is a blowhole. This is not an inclusion from the measurement of the part, and also through the microstructure. We have seen that it is an air bubble formation and it is a blowhole. So we have taken into consideration that blowhole is due to air bubble formation. That is how we have concluded. Mobin, please, can you start with the exploratory data analysis?
Yes. Next slide, please.
Again,
Okay.
yeah, please continue.
Okay. Good evening, sir. Myself, Mubin Akhtar. This is the Excel data sheet of observation which we got from Mina's company. This Excel sheet contains total 365 number of data. I'm showing just for the month of August 2020. 1 month data is this. And here you can see 11 parameters are there, like castings, number of castings to be inspected, inspected, scrap, ring blow holes, ring line holes, temperature, tilt angle of machine, silicon content, copper content, nickel content, magnesium, and percentage scrap. This is for the month of August. So I'm just showing the for the month of August. This is the data set. Next slide. For the coding part, 1 minute. For the coding part, first we imported the necessary packages. We import pandas, and we create an object df equal to pd.read underscore excel inside the parenthesis the location of the file. This code is for reading the Excel file, and we have given the location of Excel file inside the parenthesis. Next we see the top 5 rows using the code df.head inside the parenthesis 5. Similarly, we can see last 5 rows using the code df.tell. Mistakenly, it has been written columns.
I think don't go in that much of depth how you have done coding. You can, you can come to the observations and the conclusions.
Okay.
Don't explain code only, just tell this we have done, this we have done. That's it.
Okay. In exploratory data analysis, we see overview of missing values, outliers, and correlation between the missing data set. Here we checking the non-zero value and type of data using the code df.info parenthesis. Next slide. Next slide, Meena. Just before. This one. In this coding, here we are viewing the statistics of data using the function, using the code df.describe.t. For each set of variable, we can see count, minimum, standard deviation, minimum value, maximum value, and so on. Next. Here, next we are checking the number of missing values in each column of data set using the code df.isnull. We found percentage scrap has 17 missing values. Next.
So what you have
Here
done?
we imported.
So you have found out that there are some missing values in the scrap. So what you have done after that?
Sir, we fill the missing values with the mean value of that particular column.
So percentage scrap is your output, correct?
Yes, sir. Yes, sir. That is the target.
The output, why did you feel the output? Why did you imputed the output actually? So percentage scrap is output, it is not input. So you should not do it.
Sir. Sir,
so
actually,
you know exactly what is the input, but you don't know what is the effect of input. That is nothing but your output. So you should never impute your output.
Okay, sir.
Better you drop that observation if you have enough. If you don't have, you don't go for modeling.
Okay.
So how many observations do you have? How many data you have collected?
So 365 observations we have in the span of 11 months, August 2020 to June 2021.
Go back. Show me standard deviation here. So inspect. So which are data you have considered for model building? I can see actually inspected is also here. So why inspected column is present here? Have you used that for the analysis?
Yes, sir, it is there.
Inspected quantity is your input for input in your model, correct?
Yes, sir.
How it is going to influence? So it is like more you inspect, more rejection you will get. So more inspection you will do, more scrap you will get.
There is a lot of variability also in the data, what I can see. External deviation is very high.
Because that number is very high, na? They
Yes,
do
sir.
it in like 40,000, 30,000 inspection per day. So it may be 20,000 inspection per day. So 20,000 plus minus of this standard deviation is like. Yeah, what happened? You just open your PPT, no?
You open it, PPT.
Hello?
Yes, sir. Just give me a
Meena?
moment. I'll open it in a bigger folder, sir, so that everybody can see it. Sajid, share your sheet itself.
Okay.
Sajid, go ahead.
You need to wind up in next 15 minutes so that we can have another presentation.
So I think inspected quantity should not be present in model. But yeah,
Yes, sir.
you just present whatever you have done it.
Sajid, go on. Now you carry.
Please put this in projection.
Okay. Can you see the screen, sir?
No, cannot.
Now we can see your screen. Please go ahead.
Okay, sir. So we have checked this skewness and kurtosis. Skewness I have done with the lambda function applied in the num feature. Num feature I have already created an object of num feature by df.select d type. And as you can see that some of the columns have has a value more than 1. So it means that if the value is more than 1, then it is positively skewed or right skewed. If the value is less than 1, it is left skewed or negatively skewed. If the value is around 0, it's symmetric. So as you can see that RL2, percentage scrap RB2, they are right skewed.
What is this RL2 and RB2?
Ring blowhole.
Ring blowhole.
Yeah.
What is RL2 and RB2?
What is RL2 then?
These are types of blowhole.
Sir,
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 RL
RB2 is ring blowhole and RL2 is ring lines.
And
ring
what is
line.
That
percent?
is shown by me.
Ring line. So that is both defect only, na?
Yes, sir.
RB2 and RL2 is also defect.
Yes, sir. Yes, sir. It's a defect.
And how you have computed this percentage scrap?
Percentage scrap is total scrap. Sorry, the scrap which we got by number of inspected into 100%.
So basically you have used RL2 plus RB2 divided by total number of inspection, something total
No,
number
sir.
of not
No, sir.
inspection, total number of what you call produced.
I have used that scrap and number of inspected. Total scrap I have calculated, and through this scrap there is one column called scrap, and through this scrap I have calculated the percentage scrap column. I have done feature engineering in this. In the input section, input features, I have removed this scrap and percentage scrap. When I was
You tell me actually which are all you have considered for input and which is your output.
Okay, sir.
Out of all this, you tell me which are input and which are output.
Okay.
Go to that file only. Let me know. Yeah.
So can you see this? Here X is the feature variable, Y is the target. So I have dropped this date, percentage scrap and scrap. And now you can see that I have these features as my input. Inspected RB2, RL2, temperature, tilt angle, silicon content, all these things. And in the Y, that is target, I have taken as percentage scrap.
I think inspected anyway you have to remove it. RB2, RL2 also you have to remove input from input actually. I think you have not understood exactly what you want to do here. So how you are going to use this model in your organization? Can you tell me how you are going to use this model to reduce defect?
This model has many what we consider drawbacks because we have very less data and some of the important features are missing.
Let's say you have
viscosity.
infinite number of data actually. I'm not talking about, let's say your intent is to develop this type of model. How you are going to use this? So your idea is to, if I get the operating condition, I am able to predict how much defect I am going to get it, correct? And RB2, RL2 is already defect actually. So means how you are getting this as an input actually. I think this have conceptual issue.
Actually, what I feel this modeling related work they have done in hurry. They have not done it properly. The whatever was presented till we had one more round of evaluation. Na? Till that time only they have done. Now the modeling, I don't think they have done it in detail.
Yeah, they have not. It seems they have not understood the what is uh, what is the input and what is the output. That's the problem. That's
Correct.
Actually,
One of the team
yeah,
members know what is the what is the short form they have given, what is
yeah.
the full name, and like
I mean, the physical process they have not followed. So
there
what
is a
is that's why
communication
yes.
the
gap.
If they does not follow all these things, then they will do such type of mistake.
yeah, the physical process they have not understood. That's the problem. I was asking this thing.
And they cannot use this model also. Then what is use of collecting data? Lots of work they have done it
Correct.
in background. Okay, boss. Whatever you have, you just present it.
Just present it and wind it up.
Yeah, you just present it. So
So
go to heat map. Go to heat map.
yes,
See,
So
this is let
what?
yeah, please continue. Tell me.
Yeah, what is your observation from the heat map?
my observation is that these things temperature, although we think that it has highly correlated with the percentage scrap, but we are varying these temperature in a limited range. That's why we got this less number 0.082. It should have got a more, the value should be higher, but as we are changing the temperature in a very
So
fixed
your
range.
percentage scrap is not. It seems like it is not varying with
Hmm,
temperature. And
not
domain think that it has impact
hmm.
on it. You are doing somewhere some analysis is wrong.
Because the temperature which we are varying now, it's very limited. We are not abruptly changing the temperatures, and we are not getting the data from sensors. It's not real time data.
So, mean there
It's
is
an
no value
average
of this
data.
heat map. Yeah, then there is no value of this heat map. No? It doesn't like it doesn't say that what I can see here that everything is related to inspected quantity only. So no other parameters here. Huh? Is it? Is it so?
Magnesium content, it has some correlation, like it is 0.11. It's more than this temperature. And also tilt angle 0.16, and this silicon content 0.18. As this problem is very complicated, so correlation is not it's not linear, you can say. It's not very simple. The correlation is very complicated. That's why these values are very low. It's
Okay,
connected
so
to,
what you have done next?
so these are some of the insights. I've already told you the insights. Now this is the pair plot.
So you cannot understand anywhere from this also.
It,
Because I cannot see variable, I cannot interpret anything. Yeah, you can move to next plot.
yeah, come to the outcome. You have
Yeah.
done all those
What is
plots.
This
your
one,
What is the outcome from these plots?
uh, this is one is the scatter plot of temperature versus percentage scrap. And as I have told you, the correlation is not very,
No. Go
it's
to
not
next.
depending
uh,
directly. So these are,
so you have
now we
varied.
have done some box plot.
So variation is around uh, 25 degree, correct? You have varied from, let's say, 770 degree to
Hmm,
790.
yes.
20 degree variation you have.
Now we have done this. We have plotted this box plot to see the outliers. And this one is temperatures box plot. and there are very little outliers or little to no outliers. You can see that all the data are within this 25 to 75 percentile of first to third. And these are several other box plots of magnesium content, nickel content, and copper content.
Yeah, what you have done after that? Box plot is good. What you have done before that?
There was no outliers, so we haven't treated it. Now we'll move on to data pre-processing part. In this, we have imputed the missing values, which, as you told, it was not of any use because we have imputed in the output only. Now we have done this train test split, and after that we have done normalization. In this, we use this min max scaler.
Principally, you are wrong. Output, how can you impute?
Yes. These are the input features. X is our input feature and Y is the output feature. Now we have done this train test split using sklearn's model selection. And 80% we have taken as training set and 20% as the validation set or testing set. And this random state is 7 to reproduce the experiments to make it reproducible. Now we have done this normalization. Normalization.
Go to result actually. Go to result. Skip all this slide. Yeah, skip all this. How you have done modeling, that's okay.
The baseline model in this we got 0.233.
Sajid, go to the result. Rajni sir.
Rajni sir will take from here.
Before result, you have conclusion, is it? Conclusion is before result.
Done.
Hello.
Yeah, please present result.
Hello. Anyone can share the slide because I am not able to share it on my slide on. Moving. Hello.
Can you see it?
Yes, yes. Go to the next slide. Go to the result part. Next slide.
Is it okay, sir? Hello?
Yes, yes. Okay. So, sir, whatever data we have, we tried for creating a model. So the conceptually our model was wrong. That I have changed and run also, and whatever result we have found from the present model, this is the result of that model. We haven't used the moisture and viscosity, and since data was less, so the R2 score was only better in random forest regression only. We used linear regression, we used decision tree, we used random forest. So the best result was in random forest itself. Go to the next slide. Conclusion. Conclusion. So as per the present model, we can conclude that random forest model was the better, fairly well. And as per the observations are concerned, it is not mentioned in this slide. Since we have not considered the moisture and viscosity part, so if in future we can consider the moisture and viscosity, then the output can be the better. And since we are not able to vary the temperature and other features, so the correlation part can be the better, but it is not possible right now. And since we haven't received any sensor data, so we have seen the importance of IoT and CPS in this here, that IoT and CPS is playing a major role. So if we have the sensor data directly, then we can create a better model. And these are some of the observations.
So where you have collected the data? Which company?
Sir, it is for Federal Mughal, Bangalore.
Who worked there?
Sir, Meena worked there.
Okay, so they are really interested in developing all these sorts of models.
Yes, sir. Yes, sir.
Yes, sir.
So why not you do it correctly? Why not you think it properly and see exactly which are the input you have to consider and exactly which output you have to look?
Yes, sir. I have just run the after your suggestions. I have removed the unwanted features, and I have run that also.
And
But
then also you have to see exactly like see how many inspection you are doing. That also you have considered it in model. So that does not mean anything actually.
yes, sir. Yes, sir.
Correct. And then you have like type of different scrap also it in as an input in this. That also should not be here. Otherwise, what you will find that this has correlation with your output.
Yes, sir. Yes, sir.
Because output is derived from these two types of rejection, correct?
A model
Yes,
will be
sir.
biased for that if you consider the total number of observed.
Actually, you have considered output as an input actually. If you see, because RB1 and RB2, I think that different types of blowhole, you have considered it in an input. So it does not mean that whatever data you are collecting, that all has to go into such model. You have to understand exactly what input you have to consider. And in future, if you want to deploy this model, how you are going to use that, which are the input will be available for us, and what output we are expecting. All these things have to be well understood. First of all, you have to think all this line before going for model building. So process understanding is, I think, biggest thing in database modeling or any sorts of modeling. You have to understand process first.
Yes, sir. I have removed inspected RB2 and RL2 also.
Yeah, so all the thing actually has to be removed, but you also see exactly how you are calculating percentage defect. So percentage defect is like total defect divided by total number of quantity produced. Correct, Himanshu?
Yes, sir. Yes, sir.
So all the thing you have to think before doing modeling or any sorts of analysis.
Yes, sir.
So
Okay.
We will run through that and we will surely see the result of that, sir.
correct. What I
I think
suggest
you
is
should.
spend some time in
Bobby
modeling.
will agree with this. So
Yes.
Yeah. So
Yeah,
what
I
I
think you
suggest
should
is spend
present
some
again.
time. Yeah. Yes, sir. Please, you tell.
Just I think you should again present this thing, and you should show how it looks like. Okay, because again,
Okay, sir.
how much
We will
improvement?
present. We will present the last as a last entry. When the presentation of the all the candidates will be over, then we will present once again.
Yeah, why not you contact me actually? If you want to, you just explain me process. I will guide you to the choose input and output also. Okay,
sure,
if
sir.
you are interested, you can contact me. Okay,
Okay,
just
sir.
Yes, sir. Yes, sir. We will
It is
surely
already in
help.
my Kaggle account, so I am
okay.
able to run that after removing and inspected an RB2 and RL2.
But
Okay.
see, don't be so quick. Spend some time in modeling. Analyze the
Yeah.
data properly, and then you get back to us.
Okay, sir.
And
Thank you.
don't impute your output actually. So only we can impute input. That is also in worst case when we see there is no way to get all these values, then only you go for imputation. Don't play with unnecessary numbers.
And this data is not very less. Also, you guys are saying it's very.
300 data is
This
not
is good.
less actually.
This is good actually. Data is not bad. You can.
Only concern is variation of temperature. You are saying that we have not varied temperature. I don't know that 20 degree is less variation. It may be less, but
So
I can see there are 20 degrees variation. You had it in data based on that plot, whatever you have presented.
So they have done scaling in all the variables.
Yes, sir. So the temperature is like it is plus or minus 20 degrees. So we had a variation in the temperature also. We've taken the temperature also into the consideration.
So is this a less variation or okay? So actually, what is your operating band, operating temperature band?
That they should also
720
show.
plus or minus 20, sir.
So that anyway you are varying it. Then why you are claiming that you have not varied it? If it plus minus 20 means you have moved all variable in your design space, no? All your whatever space you had available.
Yes, sir.
Yeah, you should show the variation of each parameter, that input parameter that you are considering also. Okay.
So you have just curious. You have done scaling for all the variables, no?
Yes, sir.
Okay. How
Yes,
you
sir.
have how?
So min max
Scalar
scaling.
we use
Huh?
for
Min max scaling.
Min max scaling.
mean max. Yes, sir. Mean max.
Yes, so temperature, 20 degrees also, we cannot say it is less variable. Okay. This is not variability is there. 20 degree plus minus is actually huge variability. You cannot say that it's a less variable. Okay. So shall we take other presentation now, sir?
Yes,
Abhishek,
yes, Himanshu, please.
yeah, please. So you guys, you need to spend more time on modeling, and maybe you can present again. Let's see.
So Rajnikant, your other team had done very good. Last team who has presented yesterday, not yesterday, I think on Monday.
Day before yesterday, sir.
Yeah, day before yesterday, they have done nice job actually.
So
At least
their modeling part was Rajni. Just we are curious to know the modeling part in that project is done by you or by Abhishek.
Sir, we both have done the modeling part. I have used LSTM and time series part, and he used up to random forest.
Okay. So you both have done, huh?
Yes, sir. Yes, sir.
Okay, so that's good then. So yeah, so let's take other group. You guys can resume. So who is there from other group? Everyone should be there, by the way.
Yeah, thank you, sir.
Okay, bye.
Okay, bye.
Bye.
Nikhil has joined, by the way. No, na. Nikhil Suneja. So who is going to present from other group? Kunal.
Hello.
Yeah, Mitesh. Okay.
Yeah, good evening, sir. Sir, actually, Nikhil sir is in the stuck on the actually some issue, sir, and he has called you regarding the he will present letter, sir.
He will present later. So you guys will present later. So you cannot present any one of you.
No, sir, we will present together, sir.
Together you are
Letter.
going to present.
Yes, sir.
So again, we need to schedule your presentation also. One day, maybe Sunday or next week, and
Yes, sir.
that will be the only schedule you guys will be having. And please make sure everyone will be there that time. है ना?
Okay,
So,
sir.
yeah. So, sir, I think this Nikhil had some issue, but why don't you guys present? Why only Nikhil? Only Nikhil has done work on this project.
No, sir, we all three members are done, but actually main part is Nikhil, sir. Actually, he's all data from his company, sir.
Okay. So yeah, so actually, sir, Nikhil has contacted me. There is some, some breakdown happened with his car in middle of somewhere. So he has conveyed that it is he cannot. Maybe he was trying, but he's not able to join now. So let's take this presentation also later.
Yeah, no issue, Himanshu.
No problem.
There is some genuine problem. So
Yeah, no issue actually. We can excuse all this.
yeah. Okay. Thank you.
Thank you, sir.
Okay, bye.
Thank you, Dr. Sundar. Thank you, Vishal. Bye.